In section 1.3, I'm going to discuss a quantity called average velocity. Velocity describes the rate at which an object's position changes. The definition of velocity sounds a lot like the definition for speed. Remember that the speed of an object describes how fast an object is moving. Speed and velocity are related quantities, however, they're not the same thing. There are subtle but important differences between the two quantities. The main difference is that velocity describes how fast an object is moving and its direction of motion as well, where speed just describes how fast. The equation for velocity is shown here. Average velocity is equal to an object's displacement divided by the time interval of its motion. And this equation is very similar to the equation for speed, where speed is distance over time. The main difference is here we have speed, where we're calculating velocity with this equation, and that the numerator here is distance, where the numerator here is displacement. So we use a lowercase letter v to represent velocity. The standard units for velocity is the meter per second, but we can use any unit of length divided by any unit of time. This was the same as how it works for speed. Recall that delta x stands for the displacement of an object, and that displacement is a change in an object's position, where x represents the object's position. The standard unit for displacement is the meter, but again, we can use any unit of length to measure delta x, displacement. In the denominator, we have delta t, which stands for the time interval. And usually we can just use a lowercase letter t for time interval, but when t and delta t are the same, that requires the measurement of time to start at 0. And I'm going to leave it here as delta t because later in this unit, we're going to look at more complicated motions where we may have to calculate the average velocity within the middle of a problem or in the middle of an object's motion, where the beginning part is not necessarily t equals 0. For example, maybe we'll start measuring the object's initial velocity at t equals 2 seconds instead of at t equals 0. Hopefully, this example is going to be able to demonstrate the difference between average speed and average velocity. In this example, we're going to look at the motion of a top sprinter who completes a 400-meter lap in 50 seconds. Part A asks, what is the sprinter's average speed? So we can use the equation for average speed, distance over time, plug in the 400 meters for distance and 50 seconds for time, and 400 over 50 is 8 meters per second for the speed. So for part B, what is the sprinter's average velocity? For this, we need to use velocity is displacement over time. But what is the sprinter's displacement? Well, the initial position of the sprinter, x sub I, is the starting line. And the final position is exactly the same. X sub f is the finish line. Well, the finish line is the starting line. The initial and the final positions are the same. And if you recall, change in position or displacement is final position minus initial position. Well, if initial and final positions are exactly the same, then the displacement is 0. There is 0 displacement when an object starts and ends at its initial, at the same place. So the average velocity for this sprinter is 0. Notice that the speed and the velocity are different numbers. They're related quantities, but they're different in this case. Sometimes they can be the same, but here they're different. Speed and velocity are related quantities that can be categorized as scalars and vectors, respectively. All quantities that we're going to discuss this year can be categorized as either scalars or vectors. A scalar is a quantity that we can describe fully by describing its magnitude. And the magnitude of an object describes how long or how big the quantity is. Scalars are not associated with any direction. So these include things like temperature or time or distance, where we don't need to describe the direction. Vectors, on the other hand, require a description of both direction and magnitude. It's common to draw a little arrow over top of the symbol for a vector quantity to note that the symbol represents a vector quantity. For example, position is a vector quantity, so that's why you can write the little arrow over top of the X representing position. You're not required to draw an arrow above symbols for vector quantities, but you should know what it means when you see it. It's common to represent vectors by drawing an arrow pointing in the direction of the vector. And the length of the arrow indicates the magnitude of the vector. For example, if we had a vector with a magnitude of 1, and we wanted to draw an arrow representing a vector with magnitude 2, then I should draw this arrow representing the magnitude 2 twice as long as my arrow representing the vector of magnitude 1. The length of the arrow should scale with the magnitude of the vector that it represents. If we're just interested in the magnitude of the vector, then we can indicate that by the absolute value signs or the double absolute value signs. Sometimes you see that notation. As a brief discussion, I want to point out how velocity and speed are not exactly the same thing. Well, how are they related and how are they different? So there's two ways that I like to show how they are related. One way I like to explain it is to say that velocity is an object's speed plus its direction of motion. Okay? Or I can do this symbolically by saying that velocity, and I'm indicating that I'm talking specifically about the vector velocity, is just our speed s plus the direction of motion. So for example, I could say the velocity of a car was 20 miles per hour. 20 miles per hour can represent the speed north. If it's moving north, north describes the direction of motion for the car. Alternatively, we could say that speed is the magnitude of the velocity. So with my example up here, we can recognize that we are fully describing the speed by describing the magnitude of the velocity. And these absolute value symbols represent the magnitude of the velocity vector. So how are they different? Well, the main difference is direction of motion. If you're describing direction of motion, you're describing a velocity, where with speed, you're just telling me how fast. So velocity is really just speed with some extra information contained in it. And sometimes that extra bit of information is important, sometimes it isn't. And as a brief reminder, when we're discussing just one-dimensional motion, an object moving in either a positive or in a negative direction, we can indicate a direction with the plus or a minus sign. So for example, we can have an object moving in this direction, and we can indicate its velocity as positive 2 meters per second, where we could have another one moving a little bit faster, so I drew the arrow longer, and that velocity might be described as negative 3 meters per second. The difference in sign, positive versus negative, indicates that these two objects would be moving in opposite directions.